All right, tonight we're going to hear from Jonathan Vang on his talk on serverless RAG. Jonathan Vang is a guy who likes to code. Some people like to bring notebooks around with them to sketch or write in their free time. John would rather prefer to bring his laptop around and write code. When he isn't working on side projects, he is spending time with his wife and daughter at a park. He is currently an engineering manager at FMG, a marketing SaaS company, where he leads an AI engineering team. Jonathan, take it away.
Awesome. Thanks, everyone, and thank you for having me here. Let me share my screen here real quick. Oops, that's the wrong screen.
Jonathan, would you like questions at the end or as you
No,
go?
questions at any time. This is a small group or smaller group. So if you have any questions at any point, feel free to chime in, raise your hand, interrupt me. I prefer it to be more conversational. So. But just a little bit of background. I have only been doing this kind of AI LLM stuff since about April of last year is when I went full bore into it. I went to a React conference in Florida with some of my team members. I'm not big on React, so I there was also another conference that was going on called now I don't remember what the event was called, but it was a huge tech event down in Miami, and they had a whole bunch of AI talks. And so when I wasn't interested in one of the React talks, I went to that, and I just totally was kind of very impressed by what I saw there in terms of what could be the use cases for AI, not only just for coding, but for a lot of other things. And so that's when I dove in. I did some hackathons. I've just been constantly doing so much research on AI, trying to implement as much as I can. It's really a, a fast changing industry. There's so much going out in terms of like patterns and how to use it and stuff like that. So I am by no means an expert, but I've been doing this for a little over a year diving into AI. And when I'm saying AI, I'm specifically talking about large language models or applied AI. Here is the agenda for today. I'm going to demo what the serverless app that I'm going to be talking about, and then I'll dig into some foundational kind of concepts with LLMs and RAG. Like I said, if you have any questions, feel free to ask them. Usually, so everyone within AI, you could be a totally beginner, and so if you are a beginner, feel free to ask. But if everybody is more familiar too, I can just move more quickly too. So I'll kind of go at the pace of the questions. And then I'll demonstrate with some code and share some code about walking through kind of very basic LM utilization to RAG. And then I'll walk through my serverless RAG kind of proof of concept design. And then we'll have some more time for questions at the end. But like I said, if you have any questions in the meantime, feel free to ask those as well. So here is the link to the app, and I can share these slides too. Then I've also got some example docs here, but this is the front end application. This is built in Angular, but essentially what it does is it allows me to chat with my document. So I've got these documents here. The links are in the chat there for that too. Let me just open this up so that you can see some of these. So this is just like a mock use case. What I'll be sharing with RAG is RAG allows you the ability to take your internal documents or internal knowledge base, whatever is that hasn't been used to train some of these large language models, and inject them to the large language model so that you can kind of chat with them, ask it questions, do analysis on it. But this is an example of one of those documents. So this is kind of a mock. This was all AI generated, a mock SOP for maintenance inspections for a property management company. And so I've uploaded this in a number of different documents. And so if I wanted to ask a question like, hey, what is a routine property inspection procedure? Then I can go to my chat here and I can ask what routine maintenance inspection. And then behind the scenes, it'll do the magic to pull in the necessary document. There's like 7 different documents that have been uploaded, and then answer the question based on that. This is serverless, so there's a little bit of a cold start with that, but you can see here it's answered that question, and then it's gotten the reference here. And so let me just go to another document here. Let's go to property acquisition and onboarding. So let's just say, what's the process for property identification? If the knowledge base isn't that big, this isn't as impressive, but if you've got thousands of documents, thousands of pages, then having something like this at your disposal to be able to ask questions or do analysis, combine different queries and stuff like that is very like powerful to be able to have that capability. And so what we're building today is that capability that you can upload documents and then chat against those documents, bring in the required knowledge in to answer the questions. And so you can see here that it answered that question, but let's see. This one though, oddly enough, I might have uploaded this one here, the property acquisition. We can look at that in a little bit, but it's referencing a marketing and business development one. So this is a naive form of RAG too, and I'll talk a little bit about how this can be improved, but very basic RAG implementation here. So this is the application we're going to build. Any questions before I move into the rest of the presentation? All right, so code is here. Like I said, I'll also share this this presentation so you're going to get access to it. But this is that serverless RAG, and then I've got some very basic .NET or C# applications of using AI from a beginning to very basic RAG, and then we've got this serverless RAG that's can be deployed to the cloud and use. So let me just go back over here. So if I want to,
Can you
go
post
ahead.
those links in the chat right now?
Yes, I can.
I can follow along with you.
Yeah.
Maxim, we cannot hear you. Thanks, John.
So
try unmuting again or something. You might have a question. Go ahead.
is anyone else hearing feedback?
Yep, I'm trying to hunt down the culprit right now.
All right, question in the chat. How does
Question
chat?
is, yeah, no, to get data from RAG or online. I'll talk a little bit about that. That comes from the instructions or the prompt. So you can, what we're going to be doing is doing everything from the knowledge base instead of searching online. But you can give the LLM the ability to search online too. But we'll talk about that here in a little bit. But what we can also do, just to demonstrate that this works too, is let's just go to ChatGPT. So want to make this interactive. Does anybody have an SOP or a document that we can have AI generate, and then we'll ask it to search for it or process it with our RAG application? How about Jay, I was just talking to Jay about being a prepper and stuff like that. How about a comprehensive document on how to be a prepper? Make it a long document, multiple pages. So we'll see how fast this can generate. Looks like it's generating pretty quickly. What I'll do is I'll turn this into a PDF, and then I'll upload it, and then we'll ask it questions and then see how well it can answer the questions.
Hey, Jonathan, you have a question in the chat from Maxim. He said, how does chat know to get the data from RAG or online?
Yeah, and so how it does this is through the instructions or the prompt, and we'll talk a little bit more about that. But a combination of prompting and then also tools is how we would instruct the LLM on whether to retrieve documents from our knowledge base or database. It can be a database, it can be a vector database, it can be whatever the data source. And one of the examples I'm going to use is just going to be a local file that it's going to be able to retrieve. But then you can also build tools so that it can do like Google search or Bing or whatever search you want to do, and do a query online and then pull that document in. So here's this. Just going to make this into a PDF. Yes, you can. If you would like to, send me your resume. I'd be happy to upload it and we can ask questions about it. But it's not that much different than, over here in ChatGPT or any of these other LLM applications, you can upload documents, but how the scale of it is the scale of it is much, much bigger. You can have thousands and thousands of documents here. Let me download this. And then, so go to our RAG. I'll also download your resume here. Excellent. And so so how I have this is that these are divided into different organizations. So if you had different organizations that you wanted to separate, you could separate them. So in this case, I'm going to name this organization, Maxim, and I will go over and upload.
Hey, Maxim, you're having mic
Oops.
problems, so I'm going to mute you again. Apologies.
So that's been uploaded. I'm going to go over here and change the org ID to chat against the Maxim. Okay, I'm going to say. There we go. So that's, you saw that I was able to upload it. It's probably, let me just open this up here real quick. I don't want to share this with everybody unless, well, everyone already has access to it. So this is 2 pages, so it's not that much data. But, we could ask it, what,
It's neat that it includes the source.
yeah, and that can come from prompting. So you can tell it exactly how you would like to respond. You can tell it to respond in JSON, XML, however you want to instruct it. But all of this is the power of the LLM, is like you tell it exactly how you want it created and it'll create that. This is generating in Markdown. I don't have the Markdown displaying, but that could be built in kind of here. And so that's what we're going to be building today. Sure.
Could you have let's say you have the files here, like on some blob storage that's publicly accessible. Could you just hyperlink to it also?
No, you could. So one of the common patterns is that you upload things to blob storage, and then behind the scenes, there's like a change detection of the blob storage that will take it and process it. So it does need to be processed, and we're going to talk about how to process some of these documents. Because it could be a Word document, it could be an image, it could be a PDF. Some of these PDFs are not documents where you can copy and paste them. They're images, they're tables. So there's to be able to design this in such a way that it can be flexible is a little bit of a challenge, because there are so many different formats, so many different kind of ways that text and images can be represented. But I'll show a little bit of a tool or platform that you can use that can ingest.
Jonathan, I think we might have lost your audio. Yeah, can't hear you. Nope, still can't hear you.
Can you hear me now?
Yeah,
Okay. Let me switch back. How about now? Can you hear me now?
yes.
Okay. I think it might have been a network kind of thing because I saw something pop up about my network connection, which is not a good thing, but we'll continue forward and see what happens. Did I answer your question though? I don't know if when I cut off.
Yeah, you answered it and then you expanded out too. I was just thinking that instead of like where it says like the resume, I just thought that that would link to blob storage instead of like where it says like part one.
Oh, here. Yes, you
Yeah.
can. Yes, you if you wanted to build it out so that the blob storage was public and to provide that link, that is something that could do happen.
Okay, cool.
Like
Yeah,
some
yeah,
of
you
these
definitely
like
answered my question.
perplexity and stuff like that. That would definitely provide more value to be able to do that.
Jonathan, one more question in the chat from Maxim. He asks, was that document tokenized into vector database, DB?
It was. So behind the scenes, part of this serverless RAG design is taking the document, chunking it, and then storing it in a vector database that's serverless. And so for anybody that kind of doesn't know any of those terms, I will also kind of talk through those terms and walk through that too. All right, moving on. So for the absolute beginner that may, or anybody that's not used an LLM before, large language model, this is an example of how simple it is to call OpenAI. And so you've got your OpenAI key. It's just an HTTP call with some messages in here. And so the prompt is actually the system message here. So I'll show a demonstration where I'm asking it to respond like a pirate. And then usually when in chat interfaces, you collect this user content here, and then you add that in as a message, but then you essentially just make the post request to this API endpoint with the payload, and then you get the chat completion and the chat response. So essentially LLMs are just glorified autocomplete. They just do it really well. But it's not too complicated to use an LLM. It's very simple to use an LLM. And so this first thing I just want to talk through is like, hey, behind the scenes, this is the core of what we're doing over here. When we're talking through, let me just actually go through that demo too to show you that code here. So this is in a shared code base. It's kind of very basic to a little bit more advanced in terms of using LLM. So the simplest one I've got here, I'll make that call. So behind the scenes, it made, open up that code here, simplest LLM call. It's saying hello world, but it's been instructed to respond like a pirate. And so when I go to my, let's see, where did my console go? So this is the raw response from an LLM. Usually what you see is just this content here. So I instructed it to respond like a pirate. It's saying, ahoy, matey, ye be greeting the seven seas with a hearty hello world and stuff like that. But it also has metrics if you wanted to track the prompt tokens, completion tokens, total tokens. And I'm going to talk a little bit about tokens here because tokens are important for when we talk about context windows too. But behind the scenes, all of this is tokenized. And what a token is essentially it's just like a unit that the large language models use to represent different understanding of text. And so this example right here, the quick brown fox jumps over the lazy dog, the could be tokenized to 464 quick, but this is kind of interesting because it's not just the word quick. This token is space quick. And then 13, this period here can decode to 13. And so all of these LLMs have their own way of calculating tokens and stuff like that. I did provide a link over here to see if you wanted to be able to take a large body of text and see how many tokens it is. That's what you could use to do that. But behind the scenes, when you get charged by these large language models, it's per token. So input tokens with the prompts that you're sending it, but then also the generation tokens. So like all of the responses that it gave me is how they calculate the cost of it. And when we talk about context windows too, that's going to be important. So that's essentially what a token is just kind of a representation of text that the LLMs understand. Question is, was the Angular app stateless, or does it remember previous queries and is able to? No, it's not stateful. So it's just I don't think I built it as stateful. So what Corey is mentioning is when you're building these LLM applications, you can capture the context of the whole conversation. Let me go back to the code here. This is one chat. This is a reply. If we wanted it to be stateful, then we would continue to append to the conversation here and the messages would be a long array. I don't think that's how I built the Angular application. It's a simple kind of request response. But if we did, we would just need to capture that state and store it somewhere. Another question, what vector database is mostly used in Azure? I think there's a lot of different options. I know Microsoft SQL just recently added the ability to do vector databases. Cosmos DB is the big one that they push, but then there's also Azure Search that's recommended by Azure. The one I'm using is a very cheap but quick serverless offering. It's called LanceDB. I'll talk a little bit more about that when we talk through what a vector is and go through that process there. All right, so we've talked a little bit about RAG. We've thrown this term out already. So what is RAG? So for anybody that doesn't know, RAG stands for retrieval augmented generation. It's essentially one of the most, I don't know if I would say most common patterns, but it's a very common pattern to use with large language models. And really why it's needed is, so OpenAI, Anthropic, Grok, all of these large language models have been trained on so much data. Most of it probably has been from the internet, but I'm sure they've gotten a lot of other sources. But essentially, they get all this data, they feed it into the LLM. But what the LLM doesn't have, so if you go to ChatGPT and ask questions about like who the president was on this day, the history of this, all of that was discovered and used to train the LLMs. But what it doesn't have access to is like that SOP that I had or Maxim's resume. Unless that was on the internet and it was trained on it, maybe it could answer that question. But there's a large amount of data, especially within organizations, that the LLM doesn't have access to. And that's why you would need something like, I would say, augmented generation. It's taking your data, feeding it into the large language model and telling it to process it, whether it's saying, analyze this and provide a summary, or you're saying, based on this, generate this or something like that. Another reason why you need RAG is, and this has kind of changed a little bit, but I think it's still relevant, is the context windows were really small when ChatGPT first came out. And so you couldn't add some of these PDFs that we would be adding into the context window. And when I'm talking about context window, essentially, go back to this example. If this was like, I don't know, thousands of characters or something like that, that's what we're talking about, the context window. When we're feeding stuff into the LLM, both of these, the entire chat here is going to be taken into account, tokenized, and then that's the context window. It can only handle a certain amount of documents or characters or tokens. And so when we say context window, that's what we mean. And just to go over here of why kind of that's important is ChatGPT-3 had 2,000 tokens. And so very limited amount of text that you could add in there before you need to recycle, before you would need to summarize some of the conversation. And then or GBT 3.5 had 4,000, 3.5 Turbo had more, 4.0 had 128, which was a huge jump. But now we're entering into the space where we've got huge amount context window. And just to kind of give people a little context of or comparison, a fiction book could be considered 5,000 tokens. And so essentially you could potentially take a fiction book, throw it into the LLM and say, give me the cliff notes on this book, and it should be able to process all of that. So that's the importance of RAG 2 is before, I mean, it's not as big of a problem, but as you can imagine before, when you can only fit 4,000 tokens in, you'd need to choose what tokens to provide to it. And so you can't just take the whole document. Nowadays, it's very easy to take the whole document, throw it into the LLM and ask it to process it. But before, that was more of a concern. Another concern going back here is the quality can sometimes go down when there's a lot of context. And then there's also costs associated with it. And so if you don't want to spend the money for unnecessary tokens, it's better to break it down, get exactly the context you want, and then feed that into the LLM. See that we've got some questions here. Can we trust math calculations on LLMs? I haven't tried math. I would say for basic math, I would trust it over my own math, but I haven't tried complex math. But what I've heard is that it's supposed to be very good. I think I just saw something like the new DeepSeek model is supposed to be very, very good at math. And then we've got the question, does the risk of hallucination reduce by using RAG? And I'd say yes, that is one of the use cases is because these large language models are there to autocomplete, they're all about prediction. It's great when you want to like create a story, you know, if you want to create a make-believe story, like it can do that really well because essentially a story can be hallucinated, and that's what you want. You want it to be creative. You want it to just go out there and generate text. And like I said, that's all this is doing is predicting the next token. That's how these things work. It's just trying to autocomplete as best you can based on the prompt that you've given it. And so how this can reduce hallucinations is if you instruct it to only answer questions based on this knowledge base, then it can improve the accuracy, because then if it's not in the knowledge base that you provided, then you could prompt it to say, hey, I don't have this information. Whereas if you just ask the LLM without providing any context, it might make it up, because that's partially what LLMs do. They're generation machines. Any other questions?
Yeah, I have a question about this context window. You set it up, and one time you set it up and you said, talk to me like a pirate and you're marginally helpful.
Mm-hmm.
And the other context window was when you uploaded Maxim's resume, correct?
Yes. And so when we uploaded Maxim's resume, though, we broke that up. And I'll talk a little bit about that. Yeah, there's some design considerations on how you want to do that. Like the behind the scenes, the process I took was to break it up into pages. But if you know the context is going to be under a specific amount of tokens, and you're just doing one document, it's better just to throw the whole document in there.
And you can reset the context window at any time during the chat.
You would start a new chat. Yeah. So when you're using something like these chats, if you continue on with the same chat and it's stateful, as somebody mentioned, you're constantly adding to the context window. That can be helpful because it's almost like if you've ever heard of chain of thought, you're kind of walking the LLM through a thought process. You're providing more and more and more context. And so anytime it answers the next question, it understands all of that context of the conversation. Anytime you start a new conversation, it can lose all that unless you build some sort of tooling around it that it can reference previous chats and bring that knowledge into your current context. Did that answer your question?
Yeah, thank you.
Yep. All right, so we talked a little bit more about context windows. I think this is going to just continue to grow. Like I said, one of the limitations is this thing called lost in the middle. There have been some research papers that say that the context at the start of the prompt and the end of the prompt, or in all of the context, that's what the LLMs pay more attention to. The stuff in the middle can get lost, but that quality keeps increasing. You can do tests where you upload a huge document and then you inject like a little blurb in there, and then you can ask it a question about that blurb to test how effective it is to be able to process and understand everything. All right. So I talked about retrieval augmented generation. Augmented generation is just like in context learning. You say, hey, and so I'll give a little example about this. Hey, LLM, here's some information, answer the question on that. So that's augmented generation. The next step is retrieval. So before you augment it, you have some sort of retrieval strategy to get the context that's necessary to be able to provide to the LLM. And so some of the common retrieval methods are vector search, which is what some of the questions have been about today, but you don't need to do vector search. Sometimes keyword search is even better. So keyword search has been around for such a long time. You can use like Elasticsearch or Azure search, any kind of keyword search, and it should be able to, like, let's say, like in Windows, if you upload a whole bunch of documents and you type in a keyword, it would pull those documents. You can use that as a retrieval kind of method too. Vectors, we'll talk a little bit more about that, but you can also do web search. You can write custom code to retrieve the necessary content there too. So going back to this demo here, walking through kind of the next example here. So what I did was I created, okay, hold on a second here. Having trouble running this app. I'm gonna restart my Visual Studio here real quick. Make this bigger. So the next example is just a basic check. What about state. This is a basic chat application where you prompt. This one is saying, hey, you're a helpful assistant. Whenever the user mentions the secret word of the day, Bumblebee, celebrate like there's no tomorrow. So this when you hear about prompt engineering, this is the prompt here. So you can provide any sort of instruction that you want here. I'm saying, hey, if someone mentions Bumblebee, celebrate. But how this is stateful is that we've got the initial system prompt, and then we collect here the user input. And then this just constantly loops through adding the message to this chat history. And that chat history just continues to grow over time. And so let's just kind of take a look at that. Hello. What is the meaning of life? And bumblebees. And then just to show the whole state too, my name is John. What is my name? So if it wasn't stateful, when I asked it this question, what is my name? It wouldn't know my name, but I'll just set a breakpoint here real quick. Right here. And then I'll continue that conversation. Is your name? So let's just take a look at the chat history here. This is what we're talking about when we're saying stateful is every time you make the LLM call, you're sending this entire chat conversation to the LLM. And so this is that context window that we're talking about. It has my system prompt here. You can see the role of system prompt. It's got this one where I'm saying hello. It's got the assistant's response, and that just kind of continues on. And so all of this builds out to that context window, and that's how it remembers my name. Because when I send it this this chat, I'm sending that entire history to the LLM. Any questions there? So very simple. This is using the most recent 4.1 model. This model has 1 million context windows. So I would say like it's really impressive what you can do. Like I've been throwing a huge like JSON array of data analysis stuff and ask it to analyze it. And it does a really good job of being able to do that. But feel free to take a look at a basic chat app. No UI, just console to make it simple. And then the other example of what I would say is augmented generation. There's no retrieval here. This is just augmented generation, or one of the capabilities of these LLMs is in-context learning. So you provided the context in chat format, and then you can ask questions about it. Behind the scenes, that's what RAG is, but it's just a retrieval strategy on top of it. So this was a made up restaurant called Fusione. It's a Japanese Italian restaurant that I just had ChatGPT generate. But essentially, this is the prompt: is I'm saying, hey, here's how you can augment the generation. Use all of this context, and then answer questions. So this is that chat app, but with this context augmenting that chat. So I'm going to run this. Example 3. Do you have that is gluten free? And so it knows this because I provided it in the chat. So this is augmenting the generation by getting some sort of context that you have that the LLM doesn't have because it hasn't been trained on your data, throwing it in here, and then making requests, asking queries to be able to do that. So this could be a resume, this could be a menu, this could be frequently asked questions, this could be a PDF that's been made to Markdown. But essentially, it's really easy. You just take your context, you throw it in here. And then there's also, I think there was a question about how to instruct it. On top of the data, you have the prompt. And so this one is saying that you're an empathetic support assistant who works at Fusione. You could say something like that: you're not supportive, or you're not empathetic, or you speak with this certain accent, or you're risk averse, or something like that. Whatever you wanted to do, that's the kind of art of prompt engineering. If I wanted it to respond in JSON, then I would say, hey, respond in JSON. There are additional kind of tools that these models like OpenAI have, where you can very strictly say 100% respond JSON. If you just ask it to respond in JSON, sometimes it may not get it right, but there are additional kind of capabilities that OpenAI and some of these other providers have, where you can make it strict that it generates a specific schema for you. And so that's really valuable, because then you can treat these LLMs like functions, where you can say, hey, given this, generate this JSON, and then you take that JSON, you serialize it, and you've got your C# object. Any questions before we move on?
Yes. Can the contest be a website link? For example, like Yahoo Finance, would I be able to scrape the website?
It can. So that is another retrieval method. One of the things that I would recommend, there's like Firecrawl, but then there's also this website called Ina.ai. So here's an example. This one's a free one, so I'd recommend playing around with this. But what essentially this does is it takes a website and then converts it to Markdown. And so if you wanted to have that ability to take a document and convert it to Markdown, then what you could do is take that, and then you could throw it into this context, and then you could ask it questions about it.
Nice,
That makes
thank
sense.
you.
So yep. So there's also Firecrawl. That's a really popular one. This one's a free one. So if you want to mess around with taking any website and converting it to Markdown, you just kind of put the link here and it'll return the Markdown. And then you take that. So a lot of the key here with these retrieval augmented generation or augmented generation is taking it and converting it into something that makes sense to the LLM. So this does, take the image here. You can see with it being marked down, it can capture headers and stuff like that. All right, got a question. Does long dash or double star in the prompt improve tokenization of list items? So the LLMs have been trained on how to understand HTML, understand code, understand. So in this case, this is markdown with the stars and stuff like that. So headers would be emphasized, or the LLM would understand, hey, this is a header, just like I'm reading something and I understand a title or header. The LLMs, as long as it's formatted correctly, have been trained to identify that, and it could mean that it pays more attention to that, or that's more valuable to it. So if you did ask, hey, what are the titles on a page? It could, if it's formatted right, identify those for you. And then best practices for better text or prompt tokenization. Not sure in terms of tokenization. Could you say more about that, Maxim? Feel free to put it in the chat and I can revisit that. All right. Moving on. Like I mentioned, we've got augmented generation, which is just providing that in context to the chat, and then retrieval methods like we talked about web search, whether you're doing web search or you're saying to the LLM, you provided as input this website, and it can go retrieve that with some sort of tool, bring it back into the context, and then answer your questions. Okay, so then the big one, when you ever hear about RAG, that a lot of people use is vector databases. So what a vector is essentially is to anybody looking, and I'll show you this in a little bit, it's just an array of floating points, but that array of floating points has representation. It represents meaning. And so when we say you want to vectorize a word or a document or a sentence, behind the scenes, it's trying to take that and represent it in an array as best as it can. And there's a whole bunch of different embedding models. There's embedding models for code. There's embedding models for multi-embedding model for like images. So each one of these, this is something that you're going to need to take into your account for your design. If it's text, which is the most common use case, then there's a lot of embeddings that models that can do that. But so to give an example, if the vector embedding was just 3 dimensions where it's an array of 3 floating points, then this could be some of those dimensions where the first dimension is, hey, how big or small is it on a scale using a floating point? And then domestication, and then environment. So like I said, for every embedding can have their own kind of ways that they're going to do these dimensions. But when we talk about some of these embedding models for like OpenAI, text embedding 3 large, this is a 3072 dimension vector floating point. And so this represents the word beaver here. And the thing about these vectors, whenever you use these dimensions, is it's always going to return the same number of dimensions. So whether I embed beaver and I get this, or I embed how much wood would a woodchuck chuck if a woodchuck could chuck wood, same number of dimensions here. It's just represented in a completely different way. But so behind the scenes, when we talk about vector embedding, you take a word, you embed it, which results in this, and it can be, you can call it a vector or you can call it an embedding. It's the same thing. And so how that plays into vector search is that we've now provided a way to like semantically identify this. Like this array here has meaning behind it, and you can compare the meaning of this vector to another one by using some complicated math. And so cosine similarity, if you ever hear that, is one of the formulas that they use to be able to compare, hey, how similar is beaver to how much wood would woodchuck chuck if woodchuck could chuck wood? So these two can be compared, and then the output is how similar they are. So if I had, so let's just kind of take a look at some code here to walk through that. I know. Running into some challenges here with Visual Studio. My network. Here we go. All right, so let's go with the embedding example here. So this is an example of writing any type of word or string, and then it'll embed it. So if I wanted to do something like avocado, then behind the scenes, what this does, I'll show you the code here, is it will read the word here, and then there's an endpoint here where you send the string in, and then you get a response of the floating point here. So like I said, this is 3000 dimension or dimension vector here. And then there are a lot of different models. So if you wanted, if this was too large for what you're, if it's a single word, you probably don't need something large like this. But if you want to capture the meaning of a whole page or a whole paragraph, the more vectors representation, the more ability that you have to accurately identify something, similar to this here. So if we wanted to add different dimensions of, hey, how human-like is it, or how many feet does it have? Like that is how you could add different dimensions. And so the more dimensions, the more ability for it to capture meaning and semantic meaning behind these words or phrases. But one of the limitations too is that it's hard to fit a whole bunch of meanings. So let's say you throw a whole book, or let's say you're like say 10 pages and you say embed this. That's probably not going to be that accurate because it's hard to provide all of that meaning into this 3000 dimension vector. So as I mentioned, yeah, behind the scenes, it takes that input and then it sends it through an API call to this endpoint, and then you just get a response back that is this floating point, and it just puts it in there. The next example is a vector similarity search. If I go to 5 here, so behind this is the first time I've run it. So if you pull this down, I didn't also talk about how to actually run this. When you pull this down, you will need to add an environment variable for your OpenAI key. So just add this environment variable here. But what this is doing behind the scenes is for each one of these list of words here, actually, where's that list here? Here we go. So it's hard coded. It's going through each one of these and it's embedding each one of these words. And then what we can do is we can say, hey, you give it a word, and then it's going to do a similarity search. So this is a cosine similarity. Essentially, this takes two vectors and it'll say how close are these two vectors. For three-dimensional space, I mean, that's something that we can conceptually understand how close something is in three-dimensional space. But when you're talking about 3000 dimensions, that's where a computer and math are really valuable to be able to see how close 3000 dimensions vector is to another one. All right, that should be done here soon. Okay, so behind the scenes, this is vectorized, all that. I'm going to enter in the word, let's just say puppy. And so behind the scenes, that takes puppy and then vectorizes it, takes this vector, goes through all the other vectors and says, how close, what is the closest vector to this? And then in this case, it was dog here. And so let's just say, do I have alligator on here? Alligator is on here. So let's just say person. And the closest thing was a human here. So that's just a very simple example of similarity search where behind the scenes, I've got a vector array or a vector database. Essentially, Let me see if I can pull that up here real quick. So here's that vector database that we created. So each one of these, so if I look for human, this is essentially human, and then the vector embedding. Let me just try to format this. Yeah. So this is essentially a local vector database. It's represented in JSON format, but behind the scenes, if you wanted to build your own vector database, this is a vector database. And then when I ask it something like human, it vectorizes that word human, or I said person, vectorizes that, and then just scans through all of these and performs a similarity search. And then whichever one is closest is what is responded back. In this case, it was human here. So this is going to be really important when we talk about vector search, because when somebody asks a query, what happens behind the scenes is, so let me just go back to here. When I ask it, what is Maxim's interest? This sentence gets vectorized, and then it gets compared to all of the other vectors to say, which ones are these closest to, brings that context in, and then answer the questions based on that context. All right, got a question. So do we need 1 GB of storage per tokenized word? No, I wouldn't say so. And I can probably show kind of some of the storage behind some of this database stuff, but behind the scenes, it's not that. I mean, these are a lot of floating points. It is a lot of data in here, you can see, for every chunk or every word, however you want to separate your vectors. So in this case, these are single word vectors. In most cases, they're called chunks. They're chunks of text, whether it's a sentence or a page, however long you choose to chunk it. We'll talk a little bit about chunking strategy here. But each one of these chunks is vectorized, and then you can search against it to pull the most relevant chunk. Any other questions before we move on? All right, so that was the first part. I've been kind of going through these code examples as we talk, but let me continue on to the next one here to finish out these basic examples, and then we'll talk through the more advanced serverless RAG that is the main kind of topic for today. Any other questions? Well, I try to make sure this thing runs here. I don't know why my Visual Studio is having issues today. I'm going to turn off my video to see. I'm getting some system performance issues or errors in Zoom. So give this a try. Here we go. All right. So the next example here is basic RAG. So this example of basic RAG, as I mentioned, this doesn't perform vector search. This is doing retrieval, but it's doing retrieval based on a list of subjects. And so in this case, what I have is, let's say the use case is you've got a whole bunch of frequently asked questions in here. So this is for the company spam. You've got like a frequently asked questions about cooking, customer service, history, nutrition, product, sustainability, recipe. And so what this code does behind the scenes is that it will, first of all, go through the directory that I have, and which is the frequently asked questions directory here. And then it'll look through each one of these subjects. it takes that subjects and then it adds it as context to the LLM to say, here are the available subjects. And then based on this available subjects, when the user asks a question, select the most closest match subject and then answer, and then pull the document in and then answer the question. And if there isn't any subject detected, just default to the customer support. So this is introducing another very valuable tool when you're using LLMs called tools, or each one of these LLM providers calls it something different. I think the OpenAI, I don't remember if they call them tools now or function calls, but if you hear function calling or tool calling, Semantic Kernel, which I have an example of, and the other app calls them plugins, but a plugin is just a collection of functions. All the same thing though. But how this works behind the scenes is that you provide OpenAI with a schema that says, hey, here is a tool that you have access to. You can request from me to return a full frequently asked markdown of the given text. And so if it needs to be able to retrieve this and use this tool, it'll respond back and say, hey, I want you to use this tool. And then what we need to do is detect that it's saying, hey, call this tool, execute the function or the tool, and then provide that context back to the LLM so that it can answer the user's question. The question is this MCP, Model Context Protocol? It is one of the main kind of capabilities or of the protocol of the Model Context Protocol is the ability to define tools, but it also, Model Context Protocol also includes ways to prompt it and ways to give permissions to your LLM too. So let's kind of walk through this. Let me first demo it, and then we can kind of walk through what's happening here. So I've got 6 basic RAG. What is a good recipe for spam? So behind the scenes, it's understood that I said that this subject here is recipes. And so behind the scenes, it went in, pulled this data in, injected it to the LLM so that it can answer the question based on that. So this is retrieval augmented generation. There's no vector search in here. Like I said, with RAG, it doesn't have to be vector search. Most commonly when you hear RAG, people are doing vector search because it's a great way to do meaning, because if I misspelled recipe or I spelled something else, or I use another word similar to recipe, then this potentially would not work. So that's one of the benefits of vector searches. But this is still retrieval augmented generation, but it's providing a tool call to LLM saying, hey, I need this document, this recipes document, because I've instructed it to say, here are the subjects. I can respond back with, so it doesn't know this. It's just asking for it. Behind the scenes, it uses a tool. This application takes all this context, provides it back to the LLM so that the LLM can answer a question based on that. So that's a lot. I want to make some time for questions. I'll set up some breakpoints so we can kind of see what's going on here too. But this is really important to understand before we move on to some of that more advanced kind of discussion. Essentially, this is a tool call. The tool provides the context to the LLM. All right, I'm going to hit some breakpoints here. So let's just do here. Let me see, where is the context actually being pulled in here? So here you can see on line 109, this is where it's actually reading the data. So this is where the data is read. So the LLM doesn't have this context. I need to provide it that context. When we first initialize the LLM, we tell it, hey, here's a tool. here are the subjects that you have access to. If you ask me for a subject, I will read the document. I'll pull that document. I'll send that document back to you so that you can answer the question is kind of what's going on here. So let's try that again. I'm going to go to nutrition here and just see if it pulls the right document. It's spam, hopefully. All right, so here it's detecting whether or not to make a tool call. So let's just, I don't think that one is as important. All right, so when it's the LLM is asking us to make a tool call, like I said, this is some people really get confused around tool calling because the LLM, OpenAI is never going out to retrieve documents. It's always the responsibility of the application to retrieve that document. For even web search, whenever we're talking about web search, when we're talking about scraping a website, all of that is a responsibility of the program here. And so reading this file, that's a responsibility of me, but we just give the LLM the ability to make that request to us so that we can provide that context to the LLM. So here is a list of the files that it has access to. And so if it's asked for, let's just say this is a subject. So I did get it right. It detected the subject of nutrition. It's asking me to get that nutrition file. And so over here, I'm just going to run over here and read that content, read that markdown file, put it into the content, add it to the history. And then the LLM takes that, is informed by that document, and then answers based on that document. Got a question. So you catch tool name from LLM response and handle it. Yes, that's correct. So this is like, I didn't want to pull in any external, none of these have any external dependencies. All of this is HTTP calls, but I would say something like Semantic Kernel, which I have an example of, and the other application handle all this automatically for you. It's a very elegant way to do function calling. You write them like any other C# function, you just decorate it, and then it'll automatically make the calls for you. So this is kind of a back and forth with the LLM where we're saying, hey, here are the tools you have. It says, hey, use this tool. And then so it's my responsibility once it says, I need this tool, and here are the arguments, to take that, process it, and then send it back, and then the LLM responses. So it's a little bit of a few steps there, but with a lot of these frameworks like Semantic Kernel, it handles all that for you. Any questions? All right, moving on into more of the application that we're going to be, the serverless RAG. So this is a typical RAG flow here, where you've got beforehand, in order for RAG to work, if we're talking about a vector database or like some kind of keyword search, you need to take the document and process it first. So there's some pre-processing that goes on. In the case of the resume or that other document that I uploaded, this is that pre-processing. So you take the document, you need to convert it to some sort of plain text, because that's a way that we can feed the data into the embedding models, or store it in a way that it can be compared against and also retrieved. And then you take it and you can chunk it. So chunking is something that there's a lot of different strategies of how to do this. One of the naive ways, depending on how you want to do it, is if it's PDFs, you could do it by page. But if there is a lot of like thousands of words, a lot of context in there, sometimes it's harder to capture the meaning of that for vector search. So you can break it down by paragraph. If there are titles, you can say, hey, detect the titles, and then separate it by titles, separated by headers. You can do it by number of characters. So you could say after 1,000 characters, that's a chunk, and then go on, create another chunk. I would say if you're interested in this, there's a whole bunch of research out there on different methods to do chunking. But when we're talking about chunking, we're talking about taking the document and breaking it up into smaller pieces, so that it can more easily capture the meaning of it. So then the process is it generates the embeddings. So as just like I took the word dog, or how much wood will woodchuck chuck, I take that, embed it, and then I store that embedding in the vector database with the actual text. So in the vector database, you've got the text, like I showed, you've got the word human and the vector. And then once you pre-process everything, then that's when kind of the user can come in and say, hey, what is the closest word to human and that you have? So it will take that query and it will embed that query. So it's the same process of embedding these words. You take the query so that you have some sort of comparison, that you can do some math to say how similar it is. And this is all so that you can retrieve the most relevant documents to be able to answer the user's questions. So similarity search, relevant document chunks get returned. You send those relevant documents to LLM, similar to how I pulled that markdown file, send it to the LLM, and then the LLM has the context it needs to answer the questions. And then you send the response back to the user. So this is kind of the tech stack for the serverless RAG. This is a great platform called Instructor.io. I'll kind of talk a little bit more about that. I'm using OpenAI for the embedding, OpenAI for LLM, for document storage, it's all in blob storage. For functions, it's Azure Functions. And then for the vector database, there's a lot of great vector databases out there. This is a cheap kind of free open source way that you can store it as a blob storage. And so that's why I chose it here, is that this is all just blob storage, and then a function, Azure function goes and either adds to the vector database or does that vector search. Some design considerations that I mentioned is there's a lot of different ways of chunking in the code. You'll be able to see that there's this. So let me go over here now. I've got this chunker class that provides a number of different ways that you can chunk the documents. The one that I am using in the example is every page is a chunk. But if you wanted to, you could do semantic structure. You could do parent-child. So if it is like a header, you could grab the children and add it to it. Or you could do number of like characters. So chunk by title, chunk by elements, fixed size chunking. Number of different ways. Recursive character text splitting is if there's a new line or something like that. This is kind of the delimitors. So feel free to take a look at that. Let me go back here. Other considerations, retrieval strategy. Like I said, it doesn't have to be vector search. You can use keyword, you can use vector, you can use graph, or you can do hybrid. Hybrid takes both of these, keyword and vector. Depending on your use case, sometimes keyword could be better. If there are specific words that you're going to be looking for, this is all design considerations that you want to take a look into. Another consideration is how you potentially decompose a query. Some of the examples that I had were like, hey, what is Maxim's interest? But what if I just said interest? So should the LLM take that and do the similarity search, or should it ask it additional questions if it's not clear? If it's like two different queries, does it break it up and strategize on that? That's another consideration. And then the prompt, as I mentioned, how it responds, how you instruct it to use the tools is another important factor. Here is the application that I demonstrated at the beginning. We've got the client, which is that Angular application. Behind the scenes, it's making a call to a function app. That function app then will embed the query, as I mentioned, in that flow. And then it performs a similarity search to see, hey, this question, how similar is it to the documents, the chunks that are in this vector database? And then another strategy that I didn't mention is you can pull as many chunks as you want. So with similarity search, you can pull like 1,000 records. You can pull 100 records. You can pull 3 records, you can say, hey, what are the closest 3? What are the closest 5 chunks? What are the closest 10 chunks? And then depending on how much context you want to provide to the LLM, you feed that into the LLM to say, hey, based on this query and this context, answer that question, and it generates a response, and you send that back to the client. All right, so this is the RAG. This is the query and response. This is the process, the pre-processing that takes place. So when I uploaded that resume, what happens behind the scenes is uses an Azure durable function, and then it has a whole bunch of different activities. And so Azure durable functions is stateful function calling. So I've got different activities that handle different things. This can all happen. Some of this can happen, with a fan out approach too, if you wanted to do something like that. But all of these, some of these activities aren't necessary. I have them in here because if you wanted to perform analysis of each step, then you would want to save the blob. And so we'll upload a document. We'll kind of take a look behind the scenes too of what's happening here. But when you upload a document, what happens is it stores the blob, and then it ingests the document. This ingestion happens with unstructured.io, where it'll take that PDF, and then it's kind of given the responsibility of turning it into text to unstructured. I'll show you how unstructured sends it back. It's in a JSON format with semantic kind of naming conventions and stuff like that. Question here, do chunks need some shared context ID so they can be, yes. So in addition, in your vector database, most of the time you'll also have metadata associated with it, like the page, if it is a page, or the document name, or whatever you wanted to add in here. And so when you do your queries, you can not only filter by how close is this vector, but you can also filter by that metadata when you do that. In terms of timeouts from LLM processing documents, I'm not sure what the I'm guessing each one of these LLMs, whether it's Anthropic or OpenAI or Azure OpenAI, has their own kind of timeouts, but there are different ways that you can ingest the data too. The examples I had were streaming, but you can also turn streaming off and it'll process everything and send it all together. So one way that you can kind of see it working right away is you turn on streaming, and as the tokens are generated, it'll send you those tokens to display. So coming back to this, ingest the document, and then you chunk the document. Like I said, I upload the chunk just so I can perform analysis on it. And then you embed the chunk with it. So we've got chunking it just separates the text, and then you can embed that chunk, which is, going in and turning it into a vector representation. Once again upload that so that you can perform analysis on it. And then you save the embedding to a vector database here. This is a quick overview of unstructured. They can take all sorts of documents here. It's an API, you send it to it. There's different ways that it can process it, but at the end of the day, you get a JSON representation of the document here. And then you can chunk it however you want based on that. And then LanceDB is a vector database I mentioned. It's a open source vector database. It's supposed to scale very well, and it's super fast. What I like about it is you can store it in a blob storage. All right, let's go over here. So I want to be able to make sure we have time for questions here too. So if you download the program or the application, there's this infrastructure code in here if you want to run that. This is just using the Azure CLI. So you do need the Azure CLI for this. You'll need to log in. But if you run this script, it'll create all the necessary resources that you need in Azure. I will show you what that looks like. So I ran this earlier today. Essentially what it creates is 2 storage accounts, this LanceDB test, or you can name it whatever you want. You can change the variable names in here. And then it creates a function app. This one is a Python function app. Unfortunately, LanceDB, they only support Python and JavaScript. So I vibe coded. I'm not a Python developer, but I was able to get it working. And you can see that code here too. So this is that function app here. This is all Python, but behind the scenes, it's using this LanceDB library here. And so this is handling all of the storing vectors, similarity searches, indexing the vectors. That's what this API handles here. So that's what this API is. This one is the API that performs the document processing. So this has got all those activities, as I mentioned, and it'll take that, it'll embed it, it'll store it, and then it'll also make calls to the other API, the vector API, to be able to store the documents there too. So this is what it looks like behind the scenes for the blob storage. So I've got my, let me go one level up here. My blob container, in my blob container, I have things separated out into organizations. This one has the document upload. So if I wanted to see the actual document, I can get that here. This was that property management example that I mentioned before. But if we wanted to look at the Maxim one, when I uploaded that document behind the scenes, it stores the raw document. It will also, when you ingest it, it returns the JSON or the elements. And this is what we returned back from unstructured. So it can say, hey, here's a header, here's an email address, here's a title. Just semantically can separate things. And then what this chunker here does over here is it takes this JSON and it will split it up in a way that if it's a page, by page, it'll understand, okay, I need to take the things from a page, put it into a chunk, and then it'll embed it. So going back over here, we've got the elements. This is what's returned back by unstructured. And then this is the chunks. So it was, I believe it was only 2 pages. So this is kind of confusing that there's 3 here. Unless it was 3 pages. Oh, it was 3 pages. Okay, great. So the chunking strategy that I mentioned was chunk by page. So this is the first chunk here. Let me just close all these things out. I'll open up each one of these chunks. Chunk 1, chunk 2, chunk 3. So this is that next step is I'm just storing all these metadata. As I mentioned, you can choose whatever metadata you want, but this text represents all the things that are in the second page, third page, first page here. And then the next step of the ingestion pipeline is to take these. So take this text and then we embed it. So we take it, we send it to OpenAI to embed it so that we can perform similarity search on it. So that is represented chunks with embeddings. So if I open up this one, we've got that vector in here. So in addition to the text, we've got the vector embedding here. And then what we do is we take this, we send it to the vector database. And then whenever we ask questions about any number of chunks that are in the document, it will compare all the vectors in the database, see which one's the closest, and then retrieve those documents, insert them into the context window so that it can answer the questions. Any questions? I want to also leave some time for questions if there are any additional questions.
I think we're about at time anyway. Usually try to wrap up by 7.
Yeah, so, but that's pretty much wrapped up there too. So if anybody has any additional questions, I think my contact information is in my GitHub. Feel free to reach out. But yeah, hopefully it was helpful in understanding RAG.
Jonathan, I thought that was a fantastic presentation.
Thank you.
I think I learned more in the 1 hour we've been here than I have in the last 6, 8 months. Yeah. Kudos.
Same.
Keep it
That
real
was
simple.
great.
Thank you.